Alright, welcome to the last part of chapter 18, all about lenses and the ray model of light. And chapter 18.7, or the part of chapter 18, sorry, just talks about, okay, well, we've learned all of these ray tracing things, right? We learned about the three special rays, the one that goes through the middle of the lens. Parallel rays get refracted through the far focal point, and then things going through the near focal point get refracted out parallel to give us the final image. That whole process takes a really long time just to figure out, okay, is it real? Is it inverted? Is it larger? Is it smaller? And we've got to draw really accurate pictures for it to be correct. And so 18.7 focuses on the mathematical way to determine the end result of these pictures, right? And so this is actually a really good way to check yourself in your ray diagrams. Just as kind of a review, I want to go through the different variables for lenses. And so if you want to pause here, it would be a really good point to ask yourself, well, do I know what F means? Do I know what M means, or S and S prime? And I'm going to go on to give you those variables. You also find these in the notes that are posted for this video online. So here we go. F is the focal length of the lens or mirror. Both lenses and mirrors have focal lengths. There is M for the magnification. That always tells us if it is bigger or smaller than the original object. S, so all of these variables are for the actual thing that is being put in front of a lens or mirror. And then all of these are for the image that is formed by that lens or mirror. And so S represents the distance from the lens to the real object, while S prime indicates the distance from the lens or mirror to the image of that object. And H is the height of the object, while H prime is the height of the image. And P is a point on the actual object, while P prime is that same point, but on the image, right? And so if I were to label up this diagram, I would see that I have a focal point here and a focal point here. And this is just for this particular situation, so I've got a converging lens, right? Remember, think about either what they do to the rays or the ends of the lens. I have an object here that's got a height of h. It's got a point P from which these rays are emanating, and then it itself is a distance s from the lens. I have the same point P prime is down here, so the top of the candle here actually forms an image kind of upside down over here. This image distance, right, from the lens to the image is S prime, and then the height of this image is H prime, right? And so that gives you your visual. Even though we're just using equations, I still prefer to draw pictures for all of these problems. And so you're going to see me do that. I really, really encourage you to do that as well so that you know you're working with the right variables, right? There's three equations that we're going to be using, and these are the three equations. So there's the thin lens equation, and even though it says this word lens, this actually works for mirrors as well. And so we have 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length of that lens or mirror. And so what we find is that you'll be given maybe 2 of these things, and you've got to find the third, right? And we'll practice at the end of this a little bit. There is the magnification of the lens, which is what M stands for, and that's equal to -1 over the image distance and the object's distance. And then last but not least, there is a direct correlation between image distance and image height from object distance and object height. And so again, these are both, because they've got that little apostrophe or prime symbol, these are for the image, while these two are for the actual object. And it's important not to get those mixed up when you're using this equation. All right, so make sure you have those jotted down both on your formula sheet and in your notes. And this is the last thing that I'm going to make you take notes on. Now, it is on the chapter review page, so if you just want to go ahead and turn to that page, you're welcome to do that. And let me see, that is page 602. There's a good summary of these things, and it's always there for you, but I am going to make you take notes on them too. So, just like in Physics 111, we said if an object is moving to the left, then its velocity is negative. And if an object is moving to the right, then its velocity was positive. There was that sign convention that really informed a lot of our equations. And there's the same thing here. The only difference is, well, it's not as intuitive or easy to remember as the whole velocity and, left is negative and right is positive thing. So I've got this little table to help you kind of memorize what those are, and then I don't totally expect you to memorize, but I do expect you to be able to use this table. So the magnification is positive if the image is upright, and the magnification is negative if the image is inverted or upside down from that regular object, right? And so this means that the object is upright and the image is upright, object is upright, and image is inverted. So when this situation happens, the magnification gets a negative number. The focal length, we give it a positive value if we are working with a converging lens, right, like that, or a concave mirror. And then we use a negative symbol for the focal length when we've either got a diverging lens or a convex mirror, a mirror that kind of points out. S, the image, or the object distance, the object distance is always, always, always positive. And if you put a negative symbol with this, then you are doing it wrong and you will get the wrong answer. So S is always positive. However, the image distance from the lens or mirror that we're using depends on if it's a real image or a virtual image. And so just to kind of recap, a real image is one that the rays actually go through. And so it's none of that tracing back business that we did. This is where the rays actually go through that point and they actually meet there. An image is virtual if the rays don't actually converge there. And if you're having trouble with this whole real and virtual image or upright and inverted image, on page 602 in your book, they have a little summary of all of the situations that we went through in the last lecture. And so by using this, you know that if you've got, a converging lens and the object is outside of the focal point, then you are going to get a real image, and then up here I can tell you not only is it real, but it's inverted, right? And if you get something other than that, you're doing it wrong. If I have a converging lens, but the actual object is inside of the focal point, then I get a virtual image, right? These rays don't actually meet up there, and it is upright, right? And so you can kind of use this as a guide. If you want to add it to your formula sheet for easy access, that would be a really great idea. Or if you just want to put a little sticky note in your book so you can keep these straight and show me your work correctly, then that's okay too. You can do that. Right, so basically your homework problems, and I need to add a slide for that. So I'm going to do a couple of example problems, and then I'm going to give you your homework problems. All right, and so I've got these up at the top of my slide because I know you're being a good student and you've written it down, and those are on your formula sheet. And so going to the section that I'm going to draw your homework from, page 606, that is in chapter 18, I'm going to do numbers 29 and 30 just to kind of show you how I would solve these problems. All right, so number 29 says, a 2 centimeter tall object is 40 centimeters in front of a converging lens that has a 20 centimeter focal length. find h prime and s prime. And in fact, this whole problem, or this whole set of problems, asks you to find h prime and s prime, so that's a constant. All right, so my first step is to draw out this situation, right? And to do that, I need an optical axis and a converging lens. My focal length is 20 centimeters, and I've got a little tiny object that is actually outside of that focal length, right? And if you want to, you can label distances, right? And so S is 40 centimeters, which I'm going to write as 0.4 meters. And F, the focal length, is 0.2 meters to the focal point. And then if you wanted to label H, you could, and it is 0.02 meters, right? And notice I'm converting everything to meters. If you want to leave it in centimeters, you can, but you just need to make note that you're doing that. You will still get correct answers. Oops, sorry about that. All right, so I've drawn my picture. My second step is to list all of my knowns. And so even though I've kind of drawn a picture already, I'm going to make a list. And my list goes like this. The first thing that I talk about is the focal length. And I know that my focal length is 2 centimeters, so 0.02 meters. There we go. The H of my object. Yeah, I did the focal length wrong. My focal length is 20 centimeters. Whoops. That's why I draw it and do this. So focal length is 20 centimeters, so that's 0.2 meters, excuse me. The height is what's 2 centimeters, so that's 0.02 meters. And then my object distance, S, is 40 centimeters, which is 0.4 meters. Right? I'm also going to put in a space for my H prime. I don't know it, the height of my image. And my S prime, I don't know it. That's the distance of my image. H prime and S prime, and that way when I find them, I have a place to put them. The next thing that I'm going to check is my sign convention table. And so I'm going to look at this and in conjunction with this to kind of see what I can expect, right? And so I've got this situation. I've got a converging lens with an object outside the focal point. And so I know that my image is going to be real and inverted. And so, oops, there we go. I'm going to have a real and inverted image, right? And that means a few things for my sign convention. That means that my focal length is going to be positive because I'm using a converging lens. It means that my distance, and then actually both of my distances, here, oops, and here are going to be positive. So I can expect a positive value for this. All right, so my job is to find S prime and H, and I've got these values. So then I come up here and I look at my equations, and I say, okay, well, what can I find from what I have? And my eyes first jump here, but, well, I don't have H prime or S, so I can't use that one. And then I'm not being asked for the magnification, so I don't need to use that one. So that really just leaves me with my thin lens equation, and that is, in fact, the one that I'm going to use. So step 3 is that I'm going to use my thin lens equation. I'm going to plug in what I know, and I'm going to find what I need. So I know S, and I know F. I know my object distance and my focal length. So I'm going to plug those in from my handy dandy chart down here. 1 over 0.4 meters plus 1 over S prime equals 1 over, and then my focal length was 0.2 meters. Now, because these are decimals, honestly, I just go ahead and divide them out. And so 1 divided by 0.4 is 2.5. plus 1 over s prime. And I do this when possible because honestly I hate fraction addition and subtraction with the whole common denominator thing, so I avoid that if I can. Oh, and I told you I was going to simplify this one. So then 1 divided by 0.2 is 5. I'm going to put 5 there. All right. And I'm trying to solve for s prime. So I need to subtract 2.5 from both sides. And I'm running out of room, but you show your work. And I'm going to say 1 over s prime equals, and then 5 minus 2.5 is, well, 2.5. Okay. And I've got to solve for s prime. You should be working down. Well, no, I'll just do it here. So I'm going to multiply both sides by s prime to get it out of the denominator by s prime. These are going to cancel on this side, and I get 1 equals 2.5 s prime. To get s prime by itself, I need to divide now by 2.5, divide by 2.5, and 1 divided by 2.5 gives me a grand finale answer of, I gotta squeeze it in, 0.4 equals s prime. So s prime is 0.4, and I was expecting a positive answer, and I got a positive answer. So the image distance and the object distance are actually the same in this case. And I'm going to erase my work for step 3 so I can go on to step 4, which is to find h prime. All right. On your paper, you can continue to work down. So I'm going to take a second and erase here. All right. So woohoo! I found s prime, and we're going to move on to find h prime, which is the image height based on what we now have. So now we have enough information to use that third formula over on the right. And so we are going to be using this formula. And instead of rewriting it, I'm just going to come here and say step 4, and I'm going to plug in what I know. All right, so I don't know h prime. And actually, I'm going to solve out in variables. So times both sides by h. That gets rid of those. And I will go ahead and rewrite this. Then I get h prime equals s prime over s times h. Right? I just solved out those variables. And so I'm looking for h prime. I'm just going to plug and chug. I know that s prime is 0.4 meters. I know that s is also 0.4 meters, and I know the object height is 0.02 meters. Right? I don't even need a calculator to do this. I know that something divided by itself is just equal to 1, and 1 times anything is just itself. And so what I find is not only the distance the same, the height of the image is the same as well. Right? And, yep, there we go. I know it is going to be an inverted image, either because I know how to ray trace or because I was using this table. All right? I'm going to move on to number 30, and it's really just the same problem. I've got a little bit different situation, and you'll see that when I draw it out, but in terms of solving, I do it the same way. So step 1 is I'm going to draw a picture. Right? I've got a 1 centimeter tall object, and it is 10 centimeters in front of a converging lens. I got to draw my right shape. That has a 30 centimeter focal length, and so my focal point is way out, and my object is inside of the focal length. And so either because I know how to ray trace or because I'm using my cheat sheet, doesn't matter to me, you know that we are now talking about this situation, which means that we have a virtual and an upright image, right? And that means a few things for our signs. So step 2, I'm going to write out what I know. The focal length of this is 0.3 meters. That is a decimal, right? The s distance out of my object is 0.1 meters. Oh, put that decimal place back there. All right, and then the h, the height of my object, is 1 centimeter, so that converts to a 0.01 meters, right? And then again, I'm looking for s prime and h prime, but I don't know them yet, and so I'll just leave that there, right? Step 3. I know I don't have enough information to use this formula off top, so I'll be using the thin lens equation, and I'm just going to plug and chug. So 1 over s is 0.1 plus 1 over s prime. I don't know that. And then 1 over my focal length, which is 0.3. Right? And because I hate dealing with fractions, I am going to go ahead and divide those out. This is going to be 10 over 1 s prime. Right? And then this is going to be 3.33 repeating. I subtract 10 from both sides, and I wind up with 1 over s prime is equal to negative, let's see, what is that, 6.66 repeating, right? And then I need to get s prime out of the denominator, so I multiply both sides by s prime, they are going to cancel on this side, and then I get 1 equals negative 6.66 times s prime. So I'm going to divide both sides by negative 6.66. So I get 1 divided by negative 6.66 equals s prime. Alright, and then once I do that division, I wind up with negative 0.15 equals s prime, and negative 0.15 equals s prime. Alright, and so this was originally 10 centimeters away from the lens, and now it's 15 centimeters away from the lens. And I need to double check the sign convention on this s prime. So I'm going to go back to my handy dandy table, and okay, s prime is negative if I've got a virtual image. And well, okay, whew, that checks out. So for a converging lens object inside the focal length, yes, I do have a virtual image. So that answer makes sense, right? And those are my checks. If you can ray trace, this is easy. If you are not good at ray tracing, you really need this cheat table to make sure that you are doing it correctly, and you need to be drawing your own pictures. All right, so now that I've got s prime, I'm going to go on to find my h prime using the height and s formula over on the right hand side there, just like I did for the other one. I'm going to take a second to erase this. You don't erase your work, by the way, just keep working down. And then all of your homework problems are pretty much going to be solved the same way. You're going to be using that positive win and negative win table is important, as well as that little cheat sheet for ray tracing. Alright, so moving on to step 4. Remember, I multiplied both sides by h, and they cancel on this side. So I'm looking at h prime equals s prime over s times, kind of looks like division, times h. There we go. Right, and then I'm going to plug and chug. So s prime is negative 0.15, and then s was, what was it, 0.1, right? Multiplied by h, the height of the actual object, which is 0.01, right? And all of that is going to be my h prime. So I'll do my division first and then multiply, and I wind up with negative 0.015 h, right? Which is going to be 1.5 centimeters. If you want to leave it in meters, that's fine. I do 0.015, and things don't really have a negative height ever. So even though the sign convention goes there, it's only because I've got that virtual image, and that's giving me the negative sign convention. So this is 1.5 centimeters tall. It's a little bit bigger than my actual object, and when I go back to my cheat sheet, right, that makes sense for that situation. All right, which brings us to your homework. This is the last one for chapter 18, and it is going to be page 606, number 31 through 38. They are just like 29 and 30 that we just worked together, and all you're using are those 3 formulas and your few little cheat sheets and probably your completed formula sheet now to figure those out. And we'll do these in class on Monday. See you then.